Okay, let's look at this problem together. A little bit tricky, and a lot of people guess the wrong answer. Well, let's work through the math and see what happens. So the problem says that we're trying to open a door that's stuck by pulling on the doorknob in a direction perpendicular to the door. So I have my door, I have my doorknob, and I know it's going to rotate around the hinge. And I'm going to pull on this with a force F. We're going to, in the second part of the problem, we're going to look and see what happens if we tie a rope around this doorknob. And we want to know if we pull on the force with the same force, what happens to the torque. So we really want to figure out the torque. So I'm going to go through and figure out the torque. And in order for me to calculate the torque, I know that that is equal to my D cross my F, or the magnitude of my torque is equal to dF sine of theta, where theta is the angle between the displacement vector and the force vector. So these are vector quantities. So when I look at this, I know that for case 1, my torque is just equal to dF, and I know that my angle is 90 degrees, so the sine of my angle is 1. So that's pretty simple, pretty straightforward. This is how we normally get a door open. So let's look at the second case, where we have the doorknob attached to the door. We have our hinge again. And this time we're going to put a string over, and then we're going to pull with a tension force, or our force again applied there. Well, there's two ways to think about this problem. First way I can think about this problem is that I have a distance to where my string is attached, and the string is providing a tension force in this, which happens to be equal to our applied force. So in this case, I still have the same D. I have a different force, but it's the same magnitude. So the torque on this one is going to be D times F again. And again, my angle in this case is going to be 90 degrees. And 90 degrees is going to give us the value of 1 again. So I get the same torque. Some people solve this a slightly different way though. Some people will look and say, hey, that's not where the force is attached. The force is attached at a slightly different distance. And I should have drawn this in a different color. I'm going to change to green. So I'm going to attach to my doorknob, and I'm going to look at a string attached and then have my force attached to it. Well, in this case, my distance is going to be that long distance here. And I know that my force is attached at that point. So I got to ask myself, what is the angle that I need? Because I know that my torque in this case is going to be my third torque case. My third torque case is going to be equal to d prime, the magnitude of the force, times the sine of the angle that I get. And this is the angle that I have. It's that angle between the displacement vector, or to continue a line out, and the force vector. So it measures from here to there. Well, this theta 3, we have to figure out, well, that's great, except for d is changed, and now I have a sine of theta 3. So the question is, if I relate that back to my original d, how does that relate? Well, I should be able to relate d to d prime. Well, and I can see that this angle right here is going to be the same as this angle right there. So when I look at this, I see that d prime is equal to, well, let's see, I don't have d prime is equal to, I have d prime times the sine of theta 3 is equal to d. Or d prime over sine, or d prime is equal to d over sine of theta 3. This is just from the geometry. I see that this angle's here, so my distance over this distance is going to be that theta 3 there. This distance d is the opposite angle, so I use the sine function. So this means that I can substitute in. So tau 3 is equal to d over sine of theta 3, that's d prime, times my force times the sine of theta 3. And notice that a theta 3, sine of theta 3 and a sine of theta 3 cancel out, and I'm left with d times f. So the same value I came up with in the previous way of solving it still works, and it happens to be the same as the distance times the force of the first problem we solved. So in all these cases, we do not change our torque. Doesn't matter if you attach the rope on it, you're pulling on the same force at the same point that's attached to the door.